Welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is implement queue using stacks. So the problem statement goes like this: implement a first in first out queue using only two stacks. The implemented queue should support all the functions of a normal queue, which are push, peek, pop, and empty. Okay, so in the push function, an element is pushed in the back of the queue. In the pop function, an element from the front of the queue is removed and it is returned. And in the peek function, element at the front of the queue is returned, it is not removed, as it was done in pop function. Along with finding what is the element in the front of the queue, we were removing it also in pop, but in peek we will only be returning it, not removing it from the queue. Empty function returns whether the queue is empty or not. Okay, and it is mentioned that you must only use stack operations. You should not use queue, okay, or w-ended queue, anything like that. Depending upon language, a stack may not be supported natively. You may simulate a stack using list or w-ended queue as long as you only use standard operations. Okay, so queue operations you are not allowed to use, only stack standard operations you are allowed to use. So what are the stack standard operations? They are nothing but push, pop, and empty. Empty will return your stack is empty or not, and pop, so basically what happens is, let's say we are pushing elements in the stack, then they will be pushed in this order. Okay, so the element that was pushed very first time is at the bottom of the stack. So if you remove the elements, it is last in first out. So since 3 was pushed last, but when you start removing the element, 3 will be removed first. So last in, 3 is last in, and it will be the first one to get out, okay, or first one to get removed. So this is stack of these are the standard stack operations, and this is the order of the stack operations. Okay, so you should only be using these three operations, and depending upon language there is another function top. It is in C++. In Java, pop does both of the things. It removes the element and also return you the element that was removed. So that is not our concern. Our concern is all the operations should be implemented used in this manner, which is LIFO, last in first out. So stack operates in LIFO, and your queue operates in FIFO, first in first out. So let's say you were to remove some element, then 1 will be removed first instead of 3. Okay, because it was the first element that was in, and you can consider a queue something like this. You just invert your stack, okay, by 90°, or make the stack horizontal in this fashion. Or let's say someone is pushing this stack and it fall down, and it became like this. Okay, now your front will be this, it will be removed first. Okay, so anyhow, let's move back towards the problem statement. Also, in the constraints it is mentioned that every element will be ranging from 1 to 9, and at most 100 calls will be made to push, pop, peek and empty. All the calls to pop and peek are valid. What this means is that it will not be the case that your container queue that you are stimulating using stack is empty, and then the peek or pop function get called on empty queue. So you need not to check for that case. It will not happen. It is mentioned in the constraints only. Okay. Then there is a follow-up also for the problem. Can you implement the queue such that each operation is amortized of one-time complexity? Amortized is nothing but instead of considering the worst case scenario, we are considering the average case. Okay. In other words, performing an operations will take overall of n times. Okay, so we are taking average, even if one of those operations may take longer. So we are averaging out all the operations that will be done or called for. Okay, so instead of taking the worst case, we are taking average case in amortized time complexity. So we will be implementing the most optimized approach, which is also asked in this follow-up question, that we have to implement every operation in amortized of one time complexity. So let's see how we'll be doing that. And it was mentioned that we can use two stacks. So let's say this is your primary stack and this is your secondary stack. Now let's say array of element is given to you. Okay, now let's say you pushed element into the primary stack. Primary stack is the main stack which will be treated as a queue. As of now we are treating secondary stack just a helper stack. Okay, so let's say elements till 1 3 are already pushed in the stack. So 1, then 2 and then 3. So let's say after this peak operation was called, okay, or let's say pop operation is called, not peak. Now this pop operation is for queue. You should be returning 3, but if you do pop operation of stack, you will be returning you should be returning 1. If you follow the leaf order which is of stack, then you will be getting 3. So how you will be getting 1? In order to do that, what we will do is we will take these elements and move them to the secondary stack. So when these elements will be moved to the secondary stack, the secondary stack will be looking something like this. Now once these elements are gone out of your primary stack, your primary stack will be looking something like this. Okay, only element 1 will be there. Now you can easily remove it and return. Okay. Now let's say again pop operation was called. Now you may see that your primary stack is empty as of now. It is having nothing. Okay. Also, what you can do is, instead of removing one from here, you could have just moved one also to the secondary stack. That will save us some time. Okay. So you will be checking before pop operation or even peak operation if secondary stack is empty. What this means is, for example, let's say your secondary stack is something like this. After removing one for the first pop operation. Okay. So first pop operation return 1 and your secondary stack become in this state. Okay. Now for the second pop operation, as your secondary stack is not empty, you will be removing 2. Okay. So now 2 gone. Only 3 left. Now let's say there is another pop operation. Now 3 is remaining in secondary stack. Okay. Now before this pop operation, let's call 2 other operations, or let's say 3 other operations. Push 4, push 5 and push 6. So what we will be doing is, instead of pushing the elements in the secondary stack, we will be pushing elements in primary stack. Okay. So for your convenience, you can call this primary stack as input stack, so that you will be clear that which stack is getting input and which stack is getting output. Okay, input stack, and let's rename this secondary stack as output stack. Whenever pop and peak operations will be called, they will refer to output stack. It will handle pop and peak operations specifically. It will handle only push operation. Okay. So let's say these elements were pushed 4, 5 and 6. Now your stack is something like this, and your secondary stack is looking something like this. Okay, 3 is in there. And now let's say you called, after this one, you called pop. Now you see that output stack is still not empty, so we are not requiring to borrow anything from input stack, so you will be removing 3. Okay, so once 3 is gone out of the picture, then your output stack became empty, and for this particular call we returned 3. Now let's say again your pop or peak is called. For now we are considering that pop is called. Now you will see that your output stack is empty, so it will be required to borrow something from input stack. Now what we will do, we will be borrowing all the elements from the input stack whenever the output stack becomes empty. So all of these elements will be moved towards this 6, 5 and 4. LIFO order is applied here, last in first out, 4, 5 and 6. So 6 will be first, then 5, and then 4. Okay, now your input output stack will be something like this, and you will remove 4 and return it. So this is how operations will work. Now we were asked to implement every function, pop, peek and push, in order of one time. Also there was another function empty. For empty, you should be checking whether your input and output stack both are empty or not. Okay, both should be empty. If that is the case, then you are fine, and else you will be returning that your queue is not empty. Okay, so if we see, every element is entering into the output stack only once. Let me write it. Every element is entering in output stack only once. Okay, so we can say that overall amortized time complexity of all these operations, this push operation, pop and peek, reduces to order of 1. Okay, so let's see the implementation, how we have implemented this approach. This is the implementation. Let me rename these stacks. I will be calling it input stack, or let me call it push stack. For secondary, we are calling it pop cum peek stack. Okay, so by the name it is clear that which operations this stack is supporting. Okay, so initially you will be declaring two stacks, push stack and pop cum peek stack. These are the operations that they will be supporting. So for the push operation, push stack will be used only, and it will be a order of 1 time complexity operation. Then comes the pop operation. For that, pop cum peek stack will be used, and before using that stack we will check whether this stack is empty or not. If this stack is empty, then we will borrow all of the elements from the push stack. If this is the case, then borrow all of the elements from push stack or your input stack. Okay, and once you have borrowed all the elements, then you will do whatever you are required to do, whether it's a pop operation or a peek operation. Then you will remove the top of the pop cum peek stack. So if let's say a pop is called another time, then this element will be removed, okay, from this output stack or pop cum peek stack. Okay, and then it will be returned. And in peak, instead of removing the element, we are simply returning the top of popcom peak stack after checking that it should not be empty. And for the empty function, all or both of these stacks should be empty, and if that's the case, then you are fine and you will be returning true. So that is how we will be solving this particular problem. And if you are still having any doubts or any queries in general, then feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.